Good morning, dear students. Motion in a plane, 14th part. Okay, so let's continue the topic. I have already explained regarding the projectile. Okay, how we can define the term projectile? An object thrown with initial velocity and which then allowed to move under the action of gravity is called as a projectile. Okay, next, how we can define the term trajectory? The path followed by the projectile during its flight is called as what? Trajectory. Okay, the shape of the projectile which we have obtained is a parabola. Here the maximum height, the maximum vertical distance by the projectile during its time of flight is known as what? Maximum height attained by the projectile. The expression which we have obtained was it was like that way: hm is equal to v naught square sin square theta naught upon 2g. Okay. Next term, time of flight. The total time taken by the projectile from the point of projection to the point where it hits the same level again is called as what? Time of flight. So time of flight Tf is equal to 2v naught sin theta upon g. Next, horizontal range. The maximum horizontal distance travelled by the projectile during its time of flight is called as what? Horizontal range. That is r is equal to v naught square sin 2 theta upon g. Okay, in the last class I have also solved the problems on this projectile motion. So in the previous class I have obtained the expression of the centripetal acceleration. Okay, how we can define the term uniform circular motion? The motion of a particle is said to be uniform circular motion if it moves in a circular path with a constant speed. Okay, next, if the particle executes the uniform circular motion, the acceleration acting on it will be always directed towards the center of the circular path, and that acceleration is called as what? Centripetal acceleration. You can see the expression here: AC is equal to V square upon R. Okay, V is the magnitude of the velocity which remains constant, nothing but the speed, and R is the radius of the circular path. Okay. Next, AC can be also expressed in terms of angular speed, that is, we know that V is equal to R omega, and the expression we have obtained, that is omega square R. We can also express the acceleration in terms of a frequency. Okay, we know that angular velocity can be expressed in terms of frequency. Omega is equal to 2 pi nu, where nu is the frequency. Okay, so in the expression, if we consider AC is equal to omega square R and we substitute the value of omega as 2 pi nu, then we get A is equal to 4 pi square nu square R. Okay, here the main concept that we have studied in the uniform circular motion, the magnitude of the centripetal acceleration remains constant. So its direction changes continuously and always directed towards the center. Okay, here the particle is accelerated even if speed is constant, if a particle has uniform circular motion. So here, if they ask for 1 mark, give an example for the accelerated motion, that is uniform circular motion is an accelerated motion. Okay, here let's solve some problems on the centripetal acceleration concept and also on the motion in plane topic. Okay, here the problem is like this way: a stone tied to an end of a string 80 centimeter long is whirled in a horizontal circle with a constant speed. If stone makes 14 revolutions in 25 seconds, what is the magnitude and direction of acceleration of the stone? Okay, so given thing is what here? In the expression, the radius is given, nothing but the values r is equal to 80 centimeter. Okay, next, frequency value. So it makes 14 revolution in a time of 25 seconds. Okay, next, what's the question here? What you have to find out? We have to find out the magnitude of acceleration. Magnitude of acceleration is nothing but here it is centripetal acceleration. Okay. So the given thing, that is, as I already said, r is equal to 80 centimeter. Okay. In terms of meter, that is 0.8 meter. Okay. Next, frequency nu is 14 upon 25 revolution per second, nothing but the frequency unit. Omega is equal to 2 pi nu. So pi value is 22 by 7, nu value 14 by 25. If we substitute and simplify, how much you will get? 3.52 radian per second. Okay. So it's the value. Okay. So here the omega, that is acceleration angular velocity value. Okay. Okay. So here for the acceleration, use the formula, that is a is equal to omega square r. Okay. Substitute the value of omega as 3.52 and r value as 0.8 meter. Substitute and you will get the magnitude of the acceleration. Okay. Next, here the direction of acceleration is nothing but, since the body is in the uniform circular motion, so it is always directed towards the center of the circular path. Okay. Understood? Let's see the next one. An aircraft executes a horizontal loop of radius 1.0 km with a steady speed 900 km. You have to compare its acceleration with the acceleration due to gravity. Okay. Horizontal loop, there is one horizontal loop of radius 1.0 kilometer. Okay. So its speed is 900 kilometer per hour. Its speed is 900 kilometer per hour. So you have to compare the value of this acceleration with respect to acceleration due to gravity. Okay. So here, as given thing, radius is r is equal to 1 kilometer, nothing but 1000 meter. The speed is given as kilometer per hour. We have to convert in terms of SI unit, so that kilometer per hour, if we convert in terms of meter per second, the value multiplied by 5 by 18. After simplification, we will get 250 meter per second. Okay. So here the centripetal acceleration formula is AC is equal to V square by R. Substitute the value, you will get the answer as 62.5 meter per second square. Compare the value, that is AC upon G. AC value is 62.5, G value is 9.8. Then what you will get? 6.38. Okay, you will get the answer as 6.38. Okay, let's see the next problem. A cyclist is moving with a velocity of 7.5 meter per second, approaches a U-turn of radius 80 meter. He applies a brake to slow down his speed at a rate of 0.5 meter per second square. Okay. Calculate the acceleration of the cyclist on the turn. Okay. So if a person is riding a bicycle, okay, so here if it takes a U-turn from here, this acceleration, that is centripetal acceleration, will be always directed towards the center of the circular path. So let P be the point where a person takes a U-turn. Here the acceleration acting at that time, that 80 value is given, 0.5 meter per 0.5 meter per second square. Okay. So here Here the acceleration is acting in this direction, then the velocity will be opposite to that. Okay, the velocity will be in the opposite direction. Okay, so the given thing, the velocity value is 7.5. Okay, the velocity value is 7.5. Next, the radius is how much? It is 80 meter. Radius is how much? 80 meter. Okay, see here you can see the diagram. Okay, so V is 7.5, R is 80 meter. Then substitute the value of AC, V square upon R, substitute, you will get the answer as 0.7 meter per second square. Okay, so when the cyclist applies a brake at P of a circular turn, then tangential acceleration will be act opposite to the velocity. So at point P, the velocity is acting like this way and acceleration is acting in the downward direction. Okay, here 80 value, the acceleration, when a cyclist applies a brake, the acceleration acting, that value is given, how much is that? 0.5 meter per second square. So calculate the net acceleration. Okay, that is, this value is A. Okay, which makes an angle theta, that value, resultant acceleration is A. So net acceleration is what? Square root of AC upon AC square plus AT square. Okay, if we substitute, what I will get the value as 0.86 meter per second square. Okay, here theta be the angle made by the net acceleration with the velocity of a cyclist. Okay, tan theta is nothing but what? AC upon AT. Okay, AC value has been calculated. What's that? 0.7. AT value is given 0.5. So value of tan theta is 1.4. So use the log table, in that go through the natural tangent page. Well, you will get the answer of 1.4. Nearly value for the theta, that is theta is equal to 54 degree. Okay, 54 degree 28 minutes, that is somewhat 1.401 or what you will get. So the angle that made with respect to the net acceleration when a cyclist applied the brake, the value is 54 degree 28 minutes and the acceleration is 0.86 meter per second square. Okay, so let's continue with the next problem, that is, an insect trapped in a circular groove of radius 6 cm moves along groove steadily and completes 7 revolutions in 100 seconds. What is the angular speed and the linear speed of the motion? And also find the magnitude of centripetal acceleration. Okay, so and also calculate the magnitude of the centripetal acceleration. In the problem, the value of R is given. How much is that? 6 cm, isn't it? Okay, so insect which has been trapped here moves in a groove. Okay, moves in a groove and it completes 7 revolution in how many time? 100 seconds. Okay, 7 revolution in a 100 seconds. So what you have to find out? Angular speed, omega value you have to determine. Okay, and also the linear speed, v value you have to determine. Okay, so see here, R is equal to how much? 6 centimeter. 6 is equal to 6 centimeter. Convert in terms of meter. New frequency 7 upon 100 revolution per second. Okay. So the angular frequency, the omega value can be determined by using the formula omega is equal to 2 pi nu. Okay. Pi value 22 by 7. Nu value 7 by 100. Substitute and simplify. How much you will get? 0.44 radian per second. Okay. Next, V equal to omega r. Okay, that's the formula of the linear speed. Omega value is 0.44, r value 6 into 10 raised to minus 2. If you substitute, how much you will get? 2.64 into 10 raised to minus 2. Okay. So omega, the value of angular speed is how much? 0.44 radian per second. And the linear speed value is 2.64 into 10 raised to minus 2 meter per second. Okay. So here, centripetal acceleration, you can either use the formula A is equal to V square upon R. You can either use this formula or you use this formula, that is A is equal to omega square. Anyone you can use. So you will get the formula, that is answer of that value is 1.16 10 raised to minus 2 meter per second square. Okay, 1.16 meter per second square. Okay, next problem. If magnitude of A plus B is equal to magnitude of A minus B, what you have to show? Vector A is perpendicular to vector B. You have to show this. Okay. So for that, next write the given condition. Okay. Next, squaring on both sides. Then simplify. It will be A plus B dot A plus B will be equal to A minus B dot A minus B. Use apply the dot product. A dot A dot B, next B dot A, B dot B. RHS part, A dot A, next A dot B minus B dot A plus B dot B. We know that the property of the scalar product A dot, that is A dot A. A dot A is how much? A square. Okay, isn't it? A dot A is A square. Okay. Next, and it also satisfies the commutative rule. A dot B is equal to B dot A. Then if we further simplify, A square value on both sides cancels, B square value also cancels. The remaining will be 2A dot B plus 2A dot B equal to 0. Finally, it will be 4A dot B equal to 0. A dot B will be equal to 0. If A dot B is equal to 0, then only we can say two vectors are perpendicular to each other. If A dot B is equal to 0, then only, hence the proof of this problem. Okay. Next, given thing, sixth one, prove that vectors I cap plus 2j cap plus 3k cap and 2I cap minus j cap are perpendicular to each other. Okay, let's prove the given problem, that is prove that the vectors I cap plus 2j cap plus 3k cap is and 2I cap minus j cap are perpendicular to each other. Okay, so take this as vector A, first term, that is vector A is I cap plus 2j cap plus 3 cap and vector B as 2I cap minus j cap. So if it is perpendicular, then we have to prove that A dot B is equal to 0. Okay, if it is perpendicular, then what you have to prove? We have to prove A dot B is equal to 0. From the problem, write down the magnitude value of AX, BX and AY, BY, AZ, BZ. Okay, you can see here AX value is 1 and BX value is 2. Next, in the formula AY value is 2 and BY value is minus 1. Similarly, AZ value is 3 and BZ value is not there, so it is 0. Okay, substitute and simplify, we will get A dot B is equal to 0. Okay. So vector A and vector B, the given two vectors are perpendicular to each other. Okay. It's the proof of the problem. Okay. Next problem. A bullet fired at an angle of 15 degree. Okay, bullet has been fired at an angle of 15 degree with the horizontal, hits the ground 3 kilometer away. So, can we hit a target at a distance of 7 kilometer by adjusting its angle of projection? Okay, so it has been said that from the horizontal distance, a bullet has been fired. Okay, bullet has been fired with an angle of how much? 15 degree, angle of 15 degree. So here horizontally it hits the ground, the range that it has been traveled is 3 kilometer. Okay, you have to check whether it cover a target of 7 kilometer. Okay, whether it covers a target of 7 kilometer by adjusting this theta value. Okay, by adjusting its angle of projection value. Okay, let's see the proof here. Here in the problem, the range value is given, that is 3 kilometer, theta value is 15 degree. Next, formula of range of the projected, what is that? R is equal to V naught square sin 2 theta upon G. Okay, substitute the value of R and G. I will get in the format of V naught square by G, that is 6000 meter. So you know that V naught square by G is nothing but what? Maximum range expression. That is how much? 6 kilometer. If the maximum range itself is 6 kilometer and the given target is 7 kilometer, it is impossible to reach the target of the 7 kilometer. Suppose if the answer which we have obtained was 8, okay, maximum range value was 8, then we could have reached the target of 7 kilometer. Since the values, maximum range value is 6 kilometer, the bullet can never hit the target which is 7 kilometer. Okay. Next, how much high above the ground a boy can throw the ball if he is able to throw the same ball up to the maximum horizontal distance of 50 meter. Okay, so here given thing, the maximum horizontal distance thrown by that person is 50 meter. Okay, maximum range is what? 50 meter. And the formula is what? R maximum is equal to V naught square by G. So we can write the expression as V naught square by G as 50. Okay. So here the let HM be the maximum height attained by the ball with a speed of V naught. You know that when a ball reaches the maximum height, the velocity at that point will be 0. Okay, acceleration acting at that point will be minus g and the height is h. So we know the formula, that is v naught square, v square minus v naught square is equal to 2as. Substitute the value, so we will get minus v naught square is equal to 2as. Substitute the value. What you will get? V naught square is equal to 2gh. Re-end the formula. What's that? H is equal to V naught square upon 2g. V naught square upon g value is how much? Equation 1, that is 50. Substitute and you will get the value. So h is equal to 25 meter. Okay. So if the horizontal distance, maximum horizontal distance is 50 meter, then the height which has been reached, okay, by the ball will be of height 25 meter. Okay, it will be of the height that is of 25 meter. Okay, next problem. Show that vector A 2i cap minus 3j cap plus 4k cap and vector B is equal to minus 6i cap plus 9j cap minus 12k cap are parallel to each other. That is, vector A is parallel to vector B. So, in order to prove that vector A is parallel to vector B, okay, vector A is parallel to vector B. So apply the cross product, that is A cross B is equal to 0. A cross B is equal to 0. We can either use the determinant form or keep on multiplying, simplifying it by step. Okay. So directly I will use the formula. Okay. So here, if parallel, A cross B should be equal to 0. Okay. Either use the determinant form A cross B. Write I cap, J cap, K cap. Then the magnitude of AX, that is 2. Magnitude of AY, that is minus 3. Magnitude of AZ, that is 4. Next, magnitude of BX minus 6. Magnitude of BY 9. And magnitude of Z, that is BZ minus 12. So simplify it or use the formula, that is A cross B is AY BZ minus AZ BY I cap plus AZ BX minus AX BZ J cap plus AX BY minus AY BX K cap. So here AX is 2, AY is minus 3, AZ is 4, BX is minus 6, BY is 9, BZ is minus 12. Substitute. Finally, you will get A cross B is equal to 0. So, hence given two vectors are perpendicular to each other. Okay. Next problem. Prove that maximum horizontal range is 4 times the maximum height attained by the projectile which is fired along the required oblique direction. Okay. So, we know that range of the projectile formula. What's that? R is equal to V naught square sine 2 theta naught by G. Since the maximum horizontal distance is horizontal range, the formula we know R max is V naught square upon G. Only possibility, theta value 45 degree. Okay, then write the formula of maximum height. What's that? Maximum height is equal to V naught square sine square theta upon 2g. Substitute the value here, theta equal to 45 degree. The value is 1 by square root of 2. So if you substitute, you will get in the format of V naught square upon 4g. So take the ratio of R max and HM. HM upon R max will be equal to what? In the form of 1 by 4. Here V naught square value cancels, G value cancels. Only it remains 1 by 4. So hence the proof, that is R maximum is equal to 4 times that of the maximum height. That is, maximum range of the range will be equal to the 4 times the maximum height attained by the projectile. Okay, it's the end of the topic motion in a plane. Okay, in the next class let's start the new topic work, power and energy. So for the next class, be prepared for the topic, read and come the concept, that is scalar product. Okay, the properties of scalar product, everything. Okay, thank you.